Good morning once again. My name is Luisa De Amicis, and I'm working for Icons, and I will be moderating this first webinar of the REN+HOME project. REN+HOME is a new funded project that is focusing on renewable energy-based positive homes. And this first webinar will be the first one of a series of 4 webinars in which we will talk about energy efficiency, carbon emission reduction, energy poverty, and last but not least, innovative solution to tackle a sustainable transition. Before we start, let me set the rules for this webinar. So the rules of the game, which are always very important before starting. So I would kindly ask you to keep your microphone switched off. Please feel free to ask any question you think is relevant for you or for the audience. We would really like to have an interactive event. So please try to ask any burning possible questions you may have. And last but not least, enjoy the webinar, which is what we really want you to do. This event will be recorded. So here you can see the link to the project privacy notice. So please let us know in case you don't want to be recorded, or if you prefer not to appear, switch your camera off and join as a listener only. So I think this is all clear. So I'm very pleased to start with this webinar and to present today's agenda, which is very, very rich and full of interesting speakers that are mainly coming from our project, REN+HOME, but not only. We also do have a special guest from another project, which is NEUTRALPATH. So looking at the agenda, as you can see, we will start with Margherita Fabbri from RINA, who is the project coordinator of REN+HOME, and will provide us with a general overview of the project. And then we will move forward to Alessio Pacchiana from RINA, which will provide us with an overview about the positive energy buildings, and especially will focus on methodology and benefits. Then we will go even more in depth with Despina, Antipa, and Stavros Koltios. Apologies for my bad Greek pronunciation. And they will provide us also with a lot of interesting practical example. And while Despina will focus more on the life cycle assessment in buildings, Stavros will deep dive in energy assessment and certification. As mentioned, last but not least, we will have Cecilia Sals Montavillo. As I said, she's from Cartif, and she's the coordinator of NEUTRALPATH, which is another EU-funded project. Cecilia is here because the general idea of this webinar actually is to start with a key focus on buildings, and then to move forward to the general idea of district. So we all want to focus on positive energy building, but we have the ideal as well to actually have positive energy cities. So from buildings to district to cities. And that's what we want to tend to. So Without any further ado, let's start. And I'm pleased to leave the floor to Margherita Fabbri so that she can provide a brief overview of our project, REN+HOMES. Margherita, the floor is yours.
Thank you very much, Luisa. I hope you can see the presentation correctly. So nice to meet you all, and thank you for joining our first webinar. I am Margherita Fabbri, and I work in RINA Consulting, and I am the technical coordinator of REN+HOMES project that stands for Renewable Energy Based Positive Homes. So, starting from some data, the building sector in Europe is responsible for around the 30% of total energy consumption and for around the 36% of CO2 emissions, with most of the energy needs being met by fossil fuels. And also, construction and demolition waste accounts for a substantial portion of the total waste in Europe. So the European Green Deal fixed some very ambitious objectives to reduce of the 50% the greenhouse gas emission and to reach climate neutrality by 2050. So to reach these very ambitious goals, we need to develop very innovative technologies for building construction and renovation. And in this sense, positive energy building is one step above the nearly zero emission building, because in the PEB, the energy production is greater than the energy consumption, and the surplus can be shared through an intelligent grid supporting other buildings. So, REN+HOMES' main scope is basically to develop a universal methodologies for positive energy homes and residential buildings to contribute to a sustainable transition by reducing carbon emission while addressing also resource scarcity and energy poverty. These are the 7 main project outputs and objectives, and are to develop a universal methodology considering embodied emissions, circularity of materials, and resource scarcity with 6 national declinations, to select and upgrade affordable key technologies for building for both renovation and new construction, to engage residents in the decision-making process to raise awareness and influence sustainable behaviors, to test the approach in 4 countries in both renovation and new construction, to develop the best financial strategies for positive energy buildings and climate neutral buildings, and to influence decision-making at European level thanks to the liaison with 15 experts coming from an international advisory board. So the main expected outcomes of the project are the universal methodology that starts from current methodologies and will be presented by Alessio, my colleague Alessio Pacchiana, and a set of hardware and software technologies. So we are actually developing and testing a set of 23 technology packages, including 9 hardware solutions, 7 software solutions, and 7 circular plus energy homes methodologies. The technologies are widely available and affordable to develop highly replicable technology packages integrated both hardware and software solutions. The technology packages, as I was saying, integrate hardware and software solutions to streamline processes and to create smart buildings. The 23 solutions are under testing in 4 demonstrators in 4 different countries across Europe. We have 2 new construction in Innsbruck in Austria and in La Garriga in Spain, and 2 renovation in Tallinn, Estonia, and Cluj-Napoca, Romania. And finally, the consortium of our project comprehends 23 partners coming from 8 European countries. And if you want to learn more, you can check our website and our social media also to check the actual status of the project. That's all from my side, and thank you very much.
very much, Margherita. That was a very good presentation to a very good presentation to introduce our project, REN+HOME. And now I would leave the floor to Alessio Pacchiana, still from RINA. And Alessio is an energy and resource efficient engineer at RINA Consulting. And Alessio, the floor is yours.
Yeah, sorry. Here I am. Yes, I need
Welcome.
to welcome everybody. So I need to share the presentation. I actually need to know where are they stored. Sorry for this misunderstanding. Just to know
Alessio,
where.
if you want, I can share for you.
Okay, thank you so much. Sorry.
No problem. Just a minute.
Alessio, is it possible for you to switch on the camera? Would that be okay? So that's
Yes, sure.
thank you. So everybody can see the speaker.
Okay.
And of course, I just would, before Alessio starts, if anybody has questions, feel free to drop it in the chat. So we will read it out later on and we can start our discussion. Thank you.
Thank you. Sorry for this misunderstanding. So my contribution to the webinar is related to certification schemes and assessment methods for positive energy solutions. So basically we'll explore how different European methodology and certification schemes are evolving to support the transition from nearly zero energy buildings to positive energy homes. So the idea is not only to reduce energy consumption, but also to go further, to create buildings that produce, store, and share renewable energy while also improving comfort, resilience, and sustainability. And we are going to do this by doing an overview of the EU and national frameworks, also analyzing the tools and the benchmarks that support the analysis of the energy performance of buildings. So I would go to the next slide to start showing the different specific methodologies that have been developed in the project, starting from PHI methodology that basically defines the so-called PER factor, so primary energy renewable factor, that it's basically key performance indicator that shows how much renewable energy must be generated to deliver 1 unit of usable energy to the building. So it includes also storage and distribution losses, which is a hot topic in these current times due to the integration of renewable energy, stochastic renewable energy to the usage for residential scopes. So this tells us how closely the building's demand matches renewable availability. So like heating often has a higher PIR factor because storing heat seasonally is harder, while cooling has a lower one because it aligns better with renewable supply. This is an example of how well the building's demand matches renewable availability. So if we go to the next slide, we have basically a really comprehensive graph that shows us how what is the meaning behind the PER factor definition. So as we can see, there is a primary electricity from renewable sources. Only part of that is direct used directly. because of the different time frames from production to actual usage. So the analysis it's related also to the losses concerning the long-term and short-term storages that actually have some losses because associated with the energy processing. So the PR factor collects all this information and gives us a performance indicator about the availability, the efficiency which we can use actually renewable energy. So the actual load on the grid that is required to get one single unit of usable energy in the buildings. Moving on to the Romanian Green Building Council methodology. This methodology is more focused on life cycle assessment, carbon verification, and real-time monitoring to validate positive performance and track improvements over time. And yeah, uses a life cycle assessment to measure carbon impacts and integrates energy modeling and monitoring tools to continuously optimize how a building generates and uses energy. It also combines on-site renewables with smart green interaction and involve users through co-design. So this focus on co-designing with the users, it's a hot topic as well in the definition of positive energy buildings, because it can engage the users and create sensitivity and also acknowledge the a better use of the energy in the everyday use. Moving on, TALTEC methodology instead focuses on demand response integration, so the active participation of the buildings into the energy markets through shift demand. So in a situation, in a grid situation in which renewable energy production peaks needs to be shaped in order for the grid to be functional, with the help also with storage and other technologies. Also, demand response integration is a hot topic, and TALTEC focuses on the tools needed to better align energy use with renewable generation. So they use flexible loads and apply control algorithm to shift or reduce demand based on availability. So it's a model-based approach for forecasting, and also the social intent includes also social incentives like time of use pricing, and to coordinate all these elements, of course, energy management system and aggregators are necessary to for the buildings to become active players on the grid. Moving on, HPHI has developed instead methodology focused on full electrification and creating energy communities using the so-called PHPP modeling. So the optimization of energy demand, PV generation and self-consumption. So it's a model that allows to simulate the actual heat pumps, electric appliances, storage integration in the residential use. So if we go to the next slide, there is a specific example that I wanted to bring here in the webinar to show one example of this modeling. So the goal was to perform an A+ class renovation in the building by PHPP simulation and varying the number of floors and the number of and the quantity of energy produced, the power, peak power of solar plant, PV plant. And as we can see, the energy deficit grows because say for building may meet 100% of its demand, while the 6th floor building may face 30 to 35% deficit. So this monitoring is just an example of how this monitoring helps us understand when additional solutions are actually needed to push buildings beyond efficiency and go into net positive. Going on to the last but not least methodology, CERTH also includes other aspects that also are important for residential performance assessment. So multi-criteria approach that includes comfort, health, resilience, environmental impact, and also an economic performance. So it also uses building operating system for continuous monitoring and cross-path analysis to balance design choices and improve results. So in order to include also aspects like quality of life, environmental respect into the more performance and just energy performance focused methodology, this can be considered as the completion of an overall set of aspects that can fully define the building quality. So the goal, going to the last slide, the goal of this work is to create a shared foundation for designing and assessing buildings that generate more energy than they consume, basically. So it also helps harmonize tools, certification scheme, and indicators across Europe, because the final goal is to lay the groundwork for a universal positive home methodology by comparing and integrating to each other the different aspects that we have seen before in the specific methodologies upgrades that we have been analyzing and collecting all in one place. So this is the main goal of our work in the project. And if you have any questions, please do. And thank you for your attention.
Thank you very much, Alessio. I'm actually following up on Alessio's kind offer of if there is any question. So are you still alive, all the participants? Are you still awake? Are you there? So I hope so. So once again, if you have any questions, that's your opportunity to ask. Otherwise, we can move on to the next speaker, Despina Antipa from CERTH, so the Center for Research and Technology, Hellas. Despina is also an engineer, a chemical engineer, and she has been working on several EU-funded projects since more than 15 years. And now she's focusing on life cycle assessment. And this is also the key point, the key topic of her presentation. So I would leave the floor to Despina. And I hope that more questions will come up. Despina, the floor is yours.
Thank you, Luisa. Hello, everyone. Let me share my screen. Can you see the presentation?
Yes, we can see.
Okay. Let me go to presentation mode. Okay, I think it's better now. So my presentation for today's webinar has to do with the life cycle assessment in buildings. And we're going to say a few words about the Verify software tool, a tool that combines life cycle assessment and life cycle costing for buildings and districts, which is developed in-house by CERTH. CERTH was established in 2000. It is the leading research and development center in Greece, and its legal form is under private law non-profit status. We have 5 research institutes, and CERTH was listed among the top 20 European institutes with the highest participation in competitive research grants. While most of its turnover comes from this funding. We have a huge network with international partners, and we have several scientific sectors where we dive in and provide research results. I personally work for the Chemical Process and Energy Resources Institute of CERTH, where we focus on materials, energy, environment, and processes. And CERTH's role in REN+HOMES is that we lead a significant work package of this project for the development of innovative building technologies, and we lead a task where we assess these building technologies at a life cycle perspective. To do so, we use the Verify tool. But let's start with a few words for those who are not familiar yet with life cycle assessment and life cycle costing. So, what is life cycle assessment? It is an internationally standardized method for evaluating the potential environmental impacts of a product, process, or service at a life cycle perspective. So at the figure, you can see that we start from the raw material extraction, we go to the manufacturing step, we go to the distribution, to the use phase, the operational phase, and then to the end of life, to the disposal of the product. And if we apply these rules of the life cycle assessment to buildings, you can see the next figure where we have the raw material extraction for the construction of the building or of the building component. We go to the construction, we go to the operational stage where we have maintenance, repair, replacement, etc. We go to the end of life. So how do we dispose this building component or this building as a whole? And finally, we also assess other options like recycling or reuse or energy recovery. So why someone should choose life cycle assessment as an evaluation method? First of all, life cycle assessment provides a holistic view. We have noticed during the last decades that the focus, particularly for buildings, was the operational energy. However, there is also embodied energy, hidden, let's say, at a building, at a life cycle perspective, for example, with a lifespan of 50 years. So this needs also to be assessed. Of course, life cycle assessment provides informed decision making, because by this way we can identify some environmental hotspots across the building lifespan that need further attention. And also life cycle assessment enables comparisons between different building scenarios, or for example, between different renovation scenarios. Which one is the more environmentally sustainable? In addition, life cycle assessment also supports the European or even national sustainability goals, because it leads to the decarbonization of buildings towards nearly zero emission buildings or positive energy buildings, like here we assess at the REN+HOMES project. It is a key component or even a requirement for green certifications, like the environmental product declarations of building components, and it offers business and market advantages when a product is environmentally assessed across its whole life cycle. In the same manner, here is life cycle costing, which is an economic analysis to estimate the total costs of a product, process, or service across its life cycle perspective. So it's not only about the investment cost, purchase price, it's also the operational costs, including energy, water use, maintenance. It is the end-of-life costs, like how much is going to cost me to decommission or dispose. And it also accounts for residual values. For example, the revenues coming from a photovoltaic panel at the building. Taking this into account, we have created the Verify software tool in CERTH, which is the virtual integrated platform on life cycle analysis. It combines life cycle assessment and life cycle costing at a life cycle perspective, and it can be applied to buildings. This is Verify B, or to districts. This is Verify D. And of course, to do so, we were based on the international standards available. Verify B for buildings has a variety of computations, and it can also use real-time data coming from sensors from buildings for the operational energy, but it also can use historic data or synthetic data if monitoring data is not available. It has open source programming libraries. It is really easy to navigate, and it is accessed online, so there is no need to install any programs or applications at your PC. So it also performs comparative analysis of different building scenarios, and it provides comprehensive results on environmental and economic aspects. Here you can see the user interface separated to buildings and to districts. You can also see here the add-ons when we retrieve data from sensors. You can see here the operating methodology of Verify. You go to the Verify platform. You can select here your preferences as a user. For example, I need an inside temperature of the building between 20 degrees of Celsius to 25. I give an example here. The platform also retrieves sensor data. It also communicates with data repositories, and it performs lifecycle assessment and lifecycle costing, providing a report with data like emission savings, avoidance of fossil fuels, greenhouse gas emissions, and cost breakdown. Verify, apart from REN+HOMES, participates in several European funded projects because this is a dynamic work from our team, and it continuously updates and tries to be in line with the dynamic legislations of buildings, like the Levels European Framework for the Sustainability of Buildings. And here, let's go to the gist. I would like to show you an example of the Verify analysis that was performed during REN+HOMES. We have the Estonian demo. The demo site of Estonia was Academia 11-1. This is an academic hostel, belongs to Tallinn University of Technology. This is the existing building here, and this will be renovated in REN+HOMES to become a positive energy building and provide surplus of electricity to the neighboring building, Academia 11-2. So the building baseline, the existing building, and the renovation scenario were assessed with Verify B. The lifespan of the building was selected as 50 years. And the life cycle includes the raw materials, the manufacturing, the building construction, the operational phase, and the end of life. So at first, the user goes to select the input data. You can see here some geographical data necessary, building area, floor height, the temperature targets, etc. And here you can see the breakdown of the building components with HVAC systems, insulation and glazing, domestic hot water, lighting and auxiliaries. Here is the building, the existing building, the baseline. And here, excuse me, here we have the renovation scenario. So let's see what this includes. It includes an upgrade of the ventilation system, an upgrade of the lighting and auxiliaries, the replacement of glazing from double to triple, and the innovative component of REN+HOMES, which is the building integrated photovoltaics at the facade and the building applied photovoltaics at the roof. This scenario was assessed by Verify, and you can see here the results as provided by Verify. You see at the first column we have the baseline, the existing building, and the second column we have the renovation scenario, and finally we have the difference between the baseline and the renovation. For example, we see that the life primary energy demand was decreased by almost 40% from the existing building to the renovation. Another important significant result was that the lifetime global warming potential in terms of emissions per square meter was decreased by 38%. So we see that this renovation scenario already provides a lot to the environmental sustainability and energy sustainability of this building. What happens with the life cycle costs? When it comes to the whole life cycle costs, well, we also calculate the revenues from the photovoltaics. We have a drop of almost 70%, and the payback time of this renovation scenario is estimated to 8 years. Here you can see some graphs with this comparative analysis. The dark blue refers to the baseline and the light blue to the renovation. So you can see that apart from the first year of renovation, where the investment of renovation takes place, we have a steady difference of lower primary energy demand and from the renovation scenario against the baseline. And here you can see another peak because this is the 30 years of the building where we have to replace some components like ventilation, glazing, because 30 years is their own lifespan. The same behavior is expected here for the lifetime global warming potential. And here we have the life cycle costing. Again, with the dark color, you can see the baseline. With the light color, you can see the renovation scenario. So we can say that after this assessment by Verify, we have a full building renovation package. And as I said, it's ventilation and lighting upgrade, replacement of double glazing with triple, the facade BIPVs and roof BIPVs. And of course, this in Estonia, in combination with the district heating, which is based on biomass, particularly wood pellets, is a really promising investment for energy, environmental, and economic sustainability. As I also mentioned, we have a great improvement in energy, environmental, and cost behavior at a life cycle perspective. The payback of renovation was estimated in 8 years, and the extended installation of the PVs, both at the roof and the facades, led to a significant surplus of electricity. This surplus is going to be used to cover the electricity needs of the neighboring building, And this actually transforms our building to a positive energy building. We have also, for anyone who are interested to verify, we have also validated this tool by several methods coming from CIMAPRO, which is a commercial LCA software, by literature. So we have a very good validation result of around 5%. And we also have a reference when someone can see more details about how Verify works and how this is validated. Thank you very much. I hope it was not tiring for you. And I hope I gave some insights here on life cycle assessment for buildings. And I am at your disposal for any questions.
Thank you very much, Despina. Actually, I do have a quick question for you. So,
of course.
Perhaps maybe can you give us a few more information about the Verify data outputs and KPI, because it was very interesting to see that. I mean, I've seen you have touched upon it very briefly, but if you could go a little bit more in depth, I think it would be very useful.
Yes,
Thank you.
Of course, no problem at all. Verify can integrate various different data as input, okay? However, the most important data to be inputted in the Verify tool by the user have to do with the components to be assessed. So, for example, if I have a building with a glazing, I have to insert this information to Verify and say that I have this area in square meters of glazing, and what is the orientation of this glazing, north, east, and what is the U value of glazing, because we need to calculate the thermal transmittance. Even if I have the material of the frame, this will help as well, because the more data you provide, the more accurate the results. But in brief, yes, you need some technical data that refer to the building components. So when you insert the insulation data of the walls, you need to provide a U value, or you need to say this is stone wool, or this is polyurethane, for example. And when it goes to the output data, again, Verify provides a huge list of KPIs, but the main ones are the lifetime primary energy demand of building, the lifetime global warming potential, which is expressed in kilos of CO2 equivalent, yes, the lifetime costs of a building. But I would like to say that the graphs are also important because they provide the peaks where a decision maker needs to focus and see, for example, that, okay, in 30 years from now, I expect some costs due to the replacement of a building component. It helps to be proactive in the building management. I don't know if I have answered your question.
Yeah, absolutely. Yeah, thank you. Actually, it was even more comprehensive because it was also including an additional explanation about the inputs. So yeah,
okay.
Thanks. Okay, we can now move on to
Thank you.
Stravos. Thank you, Despina, once again. Stravos.
Thank you, Luisa.
You are also from CERTH, and you are an engineer as well, same as Despina, and you are also focusing a lot on EU-funded project. So now we would like to hear from you about energy assessments and certification, which I understand is your key expertise, also based on your studies and experiences. So the floor is yours.
Thank you, Luisa. Just a moment. Do you see? No. Now, do you see the full screen?
Yes, we do. Thanks.
Okay. My name is Stavros Koltsios. We are here from, along with Despina from CERTH. I am actually from the Information Technologies Institute, and today's part of the webinar is about the energy assessments and certifications. In today's part, we will focus on energy performance certification and their evolvement to renovation road mapping recommendation, as well on a second part related to smart readiness indicator, as it is briefly introduced by the EBPD, and the recommendations that we can make in our buildings in order to increase the SRI score. Starting by energy performance certificates, so we would like to examine what they are all about. So EPCs exist in the current European market. They are official documents that provide the assessment of a building, and their main goal is to explain in a simple manner to the general public how efficient a building is. That means how efficiently it reflects the building uses for heating, cooling, ventilation, and lighting, examining the energy efficiency and the environmental impact of a building. In this case, we have a simple energy rating scale, most typically in most countries rating from A to G. Some other countries we can have some classes like A plus or A plus plus that it tend to explain the energy use and the energy efficiency of the building to the simple tenant or owner of a building. Energy performance certificates, according to the country that they are implemented, can be divided into two main categories. The as designed certifications, also called the asset rating methodology, and the operational rating methodology, which examine mostly the operational phase of the building. Starting with the asset rating, here we have the calculation of the building's theoretical energy performance. In order to do it, we calculate the energy demand using the building's physics and the characteristics of the building's envelope and technical systems. All calculations are made on standardized conditions relating to the usage profiles of a building or the weather data. The data sources for our calculations are the geometry of the building and the specifications of the building envelope. Building envelope, we mean the walls, the openings, windows and doors, the roof or the floor, and the technical systems, the systems that are related to the heating, cooling, lighting, domestic hot water, and so on and so forth. The most used European standards in order to make the asset rating, to calculate the asset rating, it was up to now the 1370-90, which has been used and implemented by most of the EU countries, and its newest upgrade on 2017, the 52,000 series of standards, which is a set of rules for EU countries on how to implement this kind of rating schemes. On the other hand, we have the operational rating. In this case, we take data from energy measurements, electricity bills, energy, gas bills, and in order to calculate the efficiency of the building. So in this case, we reflect the real life usage of the building, not using standardized schedules for the use of the building, but the actual occupant behavior and the actual operational efficiency of the building. In our case, the sources of data that we use are coming from the energy consumption measurements, either from utility bills or from metering devices that we have deployed on our buildings, like building management systems or smart meters and IoT platforms. In this case, we don't have any European standards in order to make such an assessment, but from a legacy project, the D2 EPC and the Smart Living EPC, CERTH has been involved into a technical committee in order to develop and issue such a standard for making the operational rating classification on a building. So, having made both the asset and the operational rating, our main goal is to upgrade the energy efficiency of our buildings, to upgrade the EPC score. So the first thing that we have to do in this case is to identify the weak points of the buildings that we have under examination. That can be some parts of the building envelope or some technical systems that have low efficiency, and start making recommendations both on replacing parts of the building envelope, replacing the windows or insulating the walls, or as a second step, proceeding to the technical systems, we can replace existing boilers with heat pumps, with more efficient ones, and so on and so forth. The last step is the introduction of renewable energy sources on the building with the installation of photovoltaics, let's say, like Despina presented previously. A key role in this case, in the upgrade of the EPC score, is the building renovation passports. This is a term also introduced lastly by the EPBD, and we can have it in our mind as a step-by-step renovation plan to improve the building's energy performance over time, and they are based on EPCs and in order to build a renovation plan for the whole building. So far we have discussed mostly on the EPC part, and now we can say a few words about the Smart Readiness Indicator. As said, it was introduced by the Energy Performance of Buildings Directive, EPBD, in order to evaluate not how energy efficient our building is, but how smart it is. But what is the definition of smart on a building? Smart buildings have the capability as a general or in its technical systems to adapt the operation to the needs of the occupants, optimize the energy efficiency and the overall performance, and also enable the interaction with the energy grids, either the electricity grid or the district heating grids or natural gas grids. Some key objectives of the SRI indicator is that it intends to measure the building's capability to use advanced technologies and digital systems in an effective manner in order to enhance the occupant comfort, health, and well-being, enable energy savings and demand-side flexibility actions, as well as to support the integration of renewables and the interaction with the electricity grid. I will say a few words about how we calculate the SRI score on a building. So starting from the bottom and proceeding to the top, We have 9 domains that we investigate on our building. As you can see, they are related to the service of a building, from heating to domestic hot water, cooling, ventilation, and proceeding up to the EV charging facilities, the dynamic envelope, or the monitoring and control. These 9 domains are examined under 8 impact criteria categories. So each domain, let's say heating, has to be examined and scored according to its energy savings potential on the building, the maintenance and fault prediction, the human comfort they offer, the convenience, the information to the occupants, health and well-being, as well as the energy flexibility and storage. So for each cross-section of the domains and the impact criteria, there are several functionality levels that an auditor has to go examine the building and see in which level, in which functionality level the buildings addresses. So having calculated all of these long form of questionnaire, let's say, somehow, we are able to calculate the 3 key functionality levels. As said previously, they are the main focus areas of the SRI score. The energy savings, the human comfort, and the response to the grid, to the flexibility response to the grid. And having calculated all 3, we are able to calculate the overall, the total SRI score of our building. So what is the point of calculating the SRI? It is a roadmap. It provides a good diagnosis of how smart our buildings is, and we can use it in order to generate some upgrade recommendations to make our buildings even smarter according to what we intend on a building. So at the end of the day, we have an installation and deployment plan for smart technologies and control strategies on our building. Why it matters? We have the ability to transform the passive buildings into responsive and data-driven environments that can improve the energy efficiency, comfort, and operational resilience, supporting the renewable integration and the demand-side flexibility with the grid. Finally, we can enhance the building's market value and compliance with the future regulations that will have in mind to transform buildings from passive entities in relation to the grid to active players in evolving energy market. So how an SRI upgrade could look like? We can say that we could deploy smart thermostats on our rooms, or even more, we can adopt adaptive HVAC control strategies that automatically control the temperature in our indoor facilities. Another example is an intelligent lighting system or an automated shading system on our building. And lastly, a real-time monitoring system like a BMS that monitors and stores data both from energy consumption and the indoor conditions. Now I would like to make a brief presentation of the Building Dynamic Energy Assessment platform. This is a platform that we have developed under the scope of the REN+HOMES project, but very briefly to see how we have developed such tools for all of I have presented. Here we have the asset rating. In this case, we have calculated for a building the energy class score and how it is calculated, let's say according to the renewable and non-renewable part, and how each service has a percentage on the overall energy consumption of the building. We also calculated the annual energy values and values related to cost and greenhouse gas emissions, as well as you can see a monthly breakdown of the energy use per service, both in primary energy indicator and the final energy of the building. In parallel with the theoretical calculation, we can also have measurements that are used in order to calculate the energy class of the building and see what is the renewable and non-renewable part, how the services are related to the total energy consumption of the building, and again a monthly breakdown of the final energy, the primary energy, and the cost, as well as a heat map with the daily variation of the energy of the total energy consumption on our building. The road mapping tool is a tool that can help us to make some renovations on the building. So let's say we can choose to renovate some windows and the roof on our building and install a gas boiler or even a rooftop photovoltaic. And the tool is able to calculate the KPIs for each renovation, and in combination we can have the total KPI for the renovation of our building. So how much it will upgrade its energy efficiency, energy class, what is the impact of its renovation action in terms of renovation cost and payback period, as well as how it translates to the current stage and the after renovation state. Related to the SRI, we have the ability to calculate the SRI according to the methodology developed by the Commission, and by clicking all the functionality levels, let's say per service and per domain, we are able to calculate the score that is presented on the screen. In this case, we have a score of 41% and class E, let's say, and we can see a breakdown of the scores per domain, as well as the aggregation of the scores per key functionality, let's say, and a detailed breakdown of all the scores. Finally, we have created an algorithm based on artificial intelligence that is able to identify the points that our building lacks and is able to generate some recommendations in order to upgrade the functionality level in certain services. And that was all about the building, the BDA platform, Building Dynamic Energy Assessment Platform. Thank you all for your time, and I'm open to any questions you might have.
Okay, that's great. Thank you, Stavros. I do have a question for you, but I'm conscious about time, so maybe I will ask first Cecilia to make her presentation, and then we can go back to you, and I can ask a question that actually I have. Or,
Sure.
of course, if someone else wants to ask any question, of course, feel free to use our chat. Meanwhile, Cecilia, as I said, Cecilia she's working for CARTIF, and she's the coordinator of the project NEUTRALPATH, which is one of the Mission City projects. And NeutralPath is specifically focusing on positive energy districts, so PEDs, and so how they can help out enriching climate neutrality in our cities. So Cecilia will provide a presentation now, and so the floor is yours, Cecilia. Thank you.
Thank you, Luisa. Thank you for the presentation, and thank you, the audience, for attending the webinar. Sure. Can you see my screen in presentation mode?
Yes, we can.
Okay, thank you. Thank you for confirming. Yes, as Luisa has introduced, I will focus my presentation in the NeutralPath project, what we have done or what we are going to doing in one of our demos. And NeutralPath is focused on implementation and demonstration of positive and clean energy districts. Thinking in also in these clean aspects for helping neutrality of our cities. And we have two demos in Dresden and in Zaragoza, and 3 fellow cities in Banta, Ghent, in Istanbul. So what we are going to do, maybe the presentation will be quite different to my colleagues, who will be more focused in real implementation in the buildings, and maybe using or the other step to use these very interesting tools that my colleagues have presented to design and for validate the different solutions, and also for doing the data states. So here in NeutralPath, we have in our cities different perspectives of achieving this path. In Dresden, we have a virtual path considering 2 zones in the city, virtually connected through the grid, and working in both cases in buildings and in the energy facilities at district and building level. And in Zaragoza, we have a district in which we are going to focus my presentation, where we have social housing, or social residential housing, that will be maybe the core of our intervention, and a couple of schools, nursery and school, public buildings for tertiary, and also we will count with a sport the pavilion with only 4 geothermal aspects for this. And the district, it's considered, has been chosen, linked with the interest of the city of the zone, and also this district in an expansion, and would be also part of bigger aspects in the development of the city. So the importance also of our demos is to contribute to the plans of the cities to achieve the neutrality. So are more linked with mission city perspectives. And what we have done or are doing in our buildings, obviously into different perspectives, from the retrofitting part of energy, the passive measures implemented in the buildings are main questions also here. And in the residential buildings, we are going to insulate all the facade using recycled polyurethane foam from refrigerators. So this aspect of using this material contributes to the neutrality or the clean questions, because we use waste for insulation. So a very high insulation level can be used, achieved with this material. So it's an important solution here for being tested, because it's something that helps also to contribute to the circularity of our cities. So using this material will reduce the consumption, and also it's very important to use this expansion polyurethane between the walls we have in the facade. And also another solution that we are going to use also in the retrofitting will be the windows. We will work with the two sides of the windows, the carpentry and the glasses, and we will test different solutions for the also local providers. So here in this retrofitting in Zaragoza, we are involving also the local ecosystems of companies, and also the insulation material that is provided by the local supplier, and the windows and the glasses for the windows. It's also something from local companies. Here, the three glasses solution will be used in the window carpentry, and the coating, special coating, will be checked in the buildings for this glass. So this would be more or less the main aspects deployed in the buildings through patching measures. And the solution chosen for providing the energy for the district, because of course for the achieving the positiveness in the district we have to reduce the consumption of the buildings, but or the demand of the buildings, of course, but this consumption also should be provided by clean energy solutions. In this case, formerly, all of the buildings were using gas boilers for heating and domestic hot water, and this solution has been shifted into heating electrification. We will use geothermal energy only with the water heat pumps fitted by the solar energy produced in the district, for changing the heating solution in the district. For solar panels we will have in the roofs of all of the buildings. All of them will be connected, sure. So this level of integrating in the district, it's relevant. And also we will use BIPV in part of the very big buildings for producing energy. This solution also for these integrated facades, PV integrated facades. Also the glasses are new and updated and will be used for this. And this solar energy will provide the step needed for heating the buildings, because with the geothermal ring to achieve more or less 50 degrees, and with this step will be and managed with this solution. Here in NEUTRALPATH, we are more or less in the half part of the project. Later, of course, this solution will be monitored and analyzed in terms of knowing how the different solutions contribute to the bed, and how the link between them also contributes to achieve this positiveness in the district. So more or less, this would be my definition or presentation of what we are going to do in NEUTRALPATH from buildings perspective. So thank you for attending, and I'm here for solving any question you could have on it.
Thank you, Cecilia. That's very interesting. Actually, I do have a quick question. You mentioned the involvement of the local ecosystem. So
Yep.
I'm thinking about the Saragossa example. How did you engage the citizens? Which is something that is always very tricky to do. Everybody's talking about it, but then
Yeah.
do it in practice
Yeah.
is
In our case, we have to involve, or we are involving citizens for engaging them and for understanding what we are going to do in their homes, maybe, and understand the concept, and maybe use devices that could be installed there. Not for, we don't need at this special case, we don't need to engage them as maybe as co-founders, because we are thinking in, we are talking about social building houses, public social building. So the ownership, all the buildings are from the municipality. So maybe for technical or for the design aspect has been done with the municipality, but with the people that needs to respect the solutions we will install in their homes, and especially thinking in the typology of the citizens. We are working very close with the social the associations, the social parts of the groups, social groups of the citizens, and also we have deployed in the project. Maybe we are using for this with talks with the citizens a game board we have deployed for pets, for helping that playing a kind of Monopoly. They understand why we want to do this intervention, how will be better for them, for the city, and for understand the concept and accept it. and also when they will have this solution installed in their home, they will, of course, reduce the demand, but also increase the comfort inside. So it's very important for them in these questions to appreciate how their life will be better inside these homes retrofitted, and how we will do this. And working with these associations, and also using maybe our pet board game has been achieved more or less the involvement. Yeah.
Yes, the board game, it's
Yeah.
quite an innovative thing that
Yeah, and very useful
has
for
come out.
make them
Yeah.
understand the questions.
Yeah, exactly. Thank you. So we still have 7 minutes to go. So if anyone wants to ask one final question, otherwise maybe I can ask kind of a broader and general one. So I'm wondering, because you are all involved, all the speakers are involved in EU-funded projects, and you have an extensive experience in those projects. So building on your experience, how do you see projects like REN+HOMES or NEUTRALPATH to actually bridge the gap between research and citizen on the ground? Because sometimes there is there is a big discussion ongoing about how to engage citizen, how to make research closer to citizen and understandable for everyone. So I was wondering, what's your experience on that, and how do you think that your projects or projects that you have worked in actually contribute to that? I don't know if Cecilia, Margherita, Stavros, Despina
I think we
wants
have
to
been
take that one.
learning from one project to others, and from the beginning of the years for sure, to how to deal with them. So I think allowing them to take part of the decision, it's something very relevant that it's difficult to achieve, sure, but it's something that, okay, if they are part of the design phase, they will be more involved. Something is very difficult.
Yeah,
So
definitely.
it's something that we are doing the steps, but okay, I think it's the next one that should be there.
Yeah.
Yeah, I totally agree with Cecilia. And users and residents, in the case of projects dedicated to the built environment, have to be involved in the decision-making process from the beginning of the project. And it is fundamental to develop results that are widely adoptable and useful for at the end for the people who live in the building.
Yeah. No, I definitely agree, and I would say that both REN+HOMES and NEUTRALPATH are going into that direction. So well done, guys. Keep on going. Don't give up. Okay, so I think if there are no more specific questions, I think we have reached the end of our first webinar. There will be more webinar coming up. As I said, this is just the first one of a series. So if you have key topics that you think you want us to discuss or to go deep into those topics, let us know, and we will see how we can include and encourage the discussion about those things. So yeah, keep in touch. I think you probably know our contacts and social media. I know Anna made one last slide on that, so I don't know if Anna can show this last slide. If not, well, I'm sure we can continue the conversation during the next webinar. Thank you very much for connecting, and thank you very much to all the speakers that have dedicated their time to this webinar, and speak soon. Thank you.
Thank you very much for this opportunity.
Thank you very much.
Thank you very much.
Thank you.
Thank you.
Have a nice day. Bye bye.
Bye
Bye.
bye.
Bye bye.
Greetings.